smartphone which has an already written application for reading QR codes and an open platform like Android. This has Wi-Fi. You can buy Wi-Fi modules which connect to microcontrollers. So if you have a microcontroller, you have a Wi-Fi module, you can connect this using UART, for example, or SPI. It depends what kind of module you buy. This costs like 10, 15 pounds.
Is it a USB?
Sorry? No. This is not the USB dongle. These are modules that are sold separately with like certain protocols. It can be UART, it can be SPI, it can be I2C, it can be, yeah.
UART is like USB, like a cable connected.
Yeah, UART uses two lines of transmission, receive and transmit. I'm planning to talk about these protocols tomorrow in more detail, because these are the main protocols that you can connect to different other boards or read information from different sensors. So they are just protocols of transmission of information. Like TCP, IP, yeah? Same as UART. Okay. So you buy the Wi-Fi module. What it does, it connects to, okay, basically it works like this, most of them. You have your PC. This is your Wi-Fi. I'll just bring the example with the PC, then I'll switch to the microcontroller. What it does, this connects to this by Wi-Fi. You don't have to know how it connects. You just, there is this network present here in Windows. Yeah, just double click it, it connects, obtains IP automatically, and it has a special port. Let's say 192.0.1 port, I don't know, 3, yeah, for example. So port 3 is the port that you are going to receive information from. And this is connected to a microcontroller, MCU, by UART. So if you send the letter A, for example, to Wi-Fi unit, it is going to wirelessly transmit it to your computer. And if you have a software here that monitors this port, it is going to receive the letter A here. And the way around. You are going to open the port, they're going to send some information, close the port, and that information is going to arrive here. Yeah? You saying anything? No? Okay. So what you have here, you have a link, you have a Wi-Fi link, basically, which can work up to, well, in open, it depends what module you get, but okay, let's say 50 meters in open space. This Wi-Fi is going to be close to your microcontroller. So it's not even going to be 1 meter. So what you can do, you just can have a smartphone, and these smartphones have millions of codes of QR, like open source codes, which you can open and just add your protocol here. And that's it, you just fix your phone under your aircraft. It's not going to go up 2 or 3 kilometers, it's just a small competition place. It will fly over the code, it will read the information, wirelessly transmit to your Wi-Fi module, it will go to the microcontroller. It's just going to be a string. Yeah. For example, if your QR code is a coordinate, a GPS coordinate, or I don't know what it is. If it's a GPS coordinate, your microcontroller sends the coordinate to the mission control board. Yeah, and that's it. Your task is solved. You don't have to put a camera, do image recognition. If I were you, I wouldn't do it. Well, at least at this stage. So if you consider this a method, why not use it? If there are any other questions about this certain thing, I can go into more detail.
Yeah, but the thing is, the camera on the smartphones aren't that.
Is what, sorry?
They're not really good because they have lower pixels.
Okay.
That's really not relevant. Like smartphone camera is usually good enough for this.
So here's the thing. If you make tests, you will see that if you put the correct optical zoom on it, on certain distances, with quite a big step, like 2 meters or meter, it's going to work fine. So, for example, if you're not going to fly kilometers above, you're just going to fly over some ground, read code. Even if your height differs from 1 meter to 2 difference, it's not going to make that much difference. And if you make your aircraft quite stable, it's not going to be a problem. So, yeah. Without optical zoom, it might be hard. Well, also it depends on the QR code size, of course.
Yeah.
If it's too small, you will need more zoom, but optical zoom, not digital zoom. So yeah.
If we were to go about this with our own scripts and our own camera, how would we do it?
Okay, if you want to do with your own camera and your own software, it's going to be like this. First, it's going to be hard.
I mean, I have a whole tutorial of how to do it already.
Well, yeah.
I've worked it out.
Oh yeah, but that's basically what you have to say.
Here's the thing. You can have a camera which has a processor unit. There's wires connected to your processor unit, and this, with a special protocol, connects to your microcontroller. There are cameras that connect to microcontrollers with their own ready-made platforms, and they are not very expensive either. Like, you can get them for $20–30, even less. But first of all, you should choose a very fast microcontroller. You might even need a microprocessor. Yeah, because I mean the fastest microcontrollers you can get are 160 megahertz, 200 megahertz.
Yeah, I mean, the chip we currently have that we're planning on using is quite fast. It's about a gigahertz chipset.
But how do you write the software on it?
It runs Linux. We connect to it over SSH.
Okay.
We can then use the OpenCV library with a camera that works by default in Linux with the Linux driver.
Okay. Well, why don't you try it? I don't know. For me, it would be more complicated. I mean, maybe not more complicated, but I can see how to do my way more clearly than what you said. Because in what you said, you have to go look for a lot of libraries. I don't know. But in case of QR code, this is really simple. I mean, there are millions of software you can use. There are even software, that you can define an output. You can even not go into the software itself. Just leave the code alone.
That's exactly.
Yeah, you just read the output. Read the output, transfer it to the Wi-Fi module, and then it gets to your microcontroller. Yeah. Or even with some phones, you don't need even the Wi-Fi module. If you can connect to the phone for USB or something, which is even harder, so let's just take the Wi-Fi. Yeah, anyway, so.
Wi-Fi. We had something similar where you can actually look at a QR code and it returns value using a library that we had. But the problem is if you had something in the background, then you couldn't recognise the QR code itself. So how would you go about isolating the QR code within the image and ignore the background?
Pretty good.
What is your background?
So for example, if it's on this table, you might have a bit of the table in the background of the image.
Is the table white?
No, it's on the ground. So,
It's a random ground?
yeah. Like anything random that could be in the background.
Do you know the coordinate of the QR code?
Well, if you're just flying over the UAV, you wouldn't.
So the QR code can be anywhere.
Yeah.
Well, in that case, you need image recognition. You can't do it some any other way.
This is why the smartphone idea seems.
I mean,
Well, a smartphone will detect it. Will detect it more easily than your software, than the one you are going to write, because of your time, of course. If you spend more time, you will get maybe really good results. But in this case, I wouldn't risk it if you decided to participate in the competition.
Thank you.
Yeah.
Image recognition is a field they call computer vision. It's the same thing.
Sorry?
Computer vision and image recognition is the same thing or something different.
Computer vision. Well, there are like general ideas. So image recognition means you take a picture, you start analyzing it, and computer vision can be realized by image recognition. So yeah, they're kind of connected to each other, but they can mean different things. So what more can we discuss about this topic? Any new ideas? Yeah.
Yeah. The UAV obviously is going to be moving.
Yes.
There's a chance that the image that it gets of the QR code is going to be blurred. Now,
Not if you use a stabilizer.
Okay.
For example, in our case, in our aircraft, we use a super sensitive gimbal stabilizer. Even if you shake the aircraft like this, the camera keeps in one point.
Okay.
Absolutely. You have no image blurring at all.
Is that even the case as the aircraft is moving?
Yes.
Is it a mechanical thing or?
No,
you
it's
have
an
to-
electronic.
Electronic.
Well, basically, it's a mechanical thing that turns. There are two motors, two brushless
okay.
motors on it, and there is an accelerometer and the gyroscope on the camera itself. So whenever it senses a move to a direction, it turns the motors to the other way. So, and it uses PID control, which is proportional integral. Yeah. So you want to discuss this QR code more, or shall we go forward?
Can't think of anything right now.
Alright. If you remember anything, just let me know.
Again, if you have just the camera, if you don't use the smartphone, if you have the camera, and if you scan the area, it will not pick up the QR code, is it?
Guys, you need to do image recognition to find the QR code. And it depends it's not that easy to do, but it's not hard either. It just depends on how much experience you have on it. Once we solved the task a couple of years ago with our Minesweeper robot, basically we designed 3 different navigation algorithms. I can go through them if you're interested. How we navigated the robot into an open field. Basically, the first idea was what I did was this is the robot. I made a round thing on it, which had photodiodes. It was a matrix basically, and I had a laser here on a tripod. The laser could move in this axis and this axis, and we mathematically modeled the thing that basically the laser, and they have a Wi-Fi connection, well, it wasn't Wi-Fi, but it was radio frequency. So the laser points at this in the middle. Because this doesn't move, we have the absolute coordinates of this. And because there are encoders on both axes, we know how much the angle is of the laser from this and this. So we have, basically when you look at it, when you look at the field, it looks like this. In reality, it's a rectangle. So what you do is you put the laser here and just like hold from the nose of the robot and drive him around, so the robot isn't lost. If the light is here, then the robot goes forward. Basically, the task of the robot is to keep the point in the middle. That's it. This was one way of navigation. Then we switched this navigation to image recognition. What we did, we put a camera instead of laser, and we had this robot which had a cap like this, a white paper with a black rectangular thing here. Well, the whole thing was black. It wasn't like this, it was black. Yeah? So the camera could detect the white because it was going on soil. It is not that bright. Yeah, so it's kind of black brownish. So it detected the white paper on the black soil, and it could find the rectangle here. It could determine if this is, because it wasn't in the middle, it could determine if it was on the front or it was on the backward. So from the angle, it could know where the robot is looking for, and it could drive the robot around with Wi-Fi. We managed to do this quite well. Of course, we suffered a month, but the results were fine. I mean, considering this, you could find the QR code because it's again white and black with the contrast. It's quite good. You can find it, but again, because our camera wasn't moving, I don't know how accurate your mission will be, your task will be solved. So I don't know. But you can do it. But on second thought, you don't have time to do it. So we just come to time. Everything's possible in the right time. My advice to you would be, in this case, use as many ready-made things as you can. It's against our philosophy, to be honest. But again, we don't go participate in competitions that we're not ready for. But in this case, you should just use as many things as you can.
So will a smartphone capture the QR code automatically?
Yeah. Most of the software, whenever they detect it, whenever you enter the region of capturing, they start zooming in and out and focusing, and then whenever they find it, they just capture it and return you the information that is stored in the code. So you can use that regime. You can put that regime in a loop, so it always searches for a QR code. And when you fly around, you can fly really slowly. Or you can, what you can do, you can fly stop, and make a matrix of the field. Like your thing, you can fly over the field and scan. I don't know. And you should choose the best software.
I guess we'll be able to decide better when we have the specifications of the competition.
No, we're doing this for the first step. As a first step, we need to make QR system.
You know what I would do in your like situation? I would take a quadcopter, a remote control quadcopter. I would put a QR code in one, I don't know, corner of the room, and I'll just drive the quadcopter around in one altitude to see if it captures it. Before getting into complicated things like what we get, what we don't, how we do it, just test this one, really easy. And then take the smartphone out, see if it captures it. Okay. That's a good step, I think, you can start with. Then you can change the speed of the quadcopter, you can change the altitude. I mean, it's just debugging, you know? You have to go for it.
How do you like scan indoor? Like how do you make the robot to know where exactly it is, or make a map of?
Okay. It depends on the distances, and it depends on what precision you want. So basically, if you are in a room like this, you shall be